Section 1.3, trig functions. Please complete the warm-up and refer to the discussion board if you have any questions. Let's take a look at our first set of trig functions. First of all, recall that we already talked about an angle being in standard position, where I have my initial side on the x-axis, and then my terminal side is going to be either a clockwise or counterclockwise movement from my initial side. And when this occurs, we're going to have a point that's going to fall inside of some quadrant, and it's going to have a related x and y value. So as you can see the diagram that is associated with the definition we're talking about, we want to let a point xy be a point that's not on the origin and is not part of the initial side. So it will be a point that's in some quadrant in our coordinate plane. And that will create an angle that will give us a standard position where I have an initial side on my x-axis and a terminal side in some other quadrant. We're going to name the angle theta, and that's the symbol for theta. And what we need to do is actually find the distance of that point from the origin, and they're going to call that r. So I have 3 points on my triangle. I have an x value that's related to my x coordinate. I have a y value that's related to my y coordinate, and that generates the distance from the origin to point xy that we're going to denote as r. Now, the easiest way to really take a look at this, as is diagrammed in my definition, is by the distance formula. But a better way to look at that is to realize what was formed is a right triangle. A right triangle is formed when I have a triangle or an angle in standard position. When that occurs, I can simply use the Pythagorean theorem, which we already know is x squared plus y squared, in this case, would equal r squared. And remember, if I solve that problem, I'm going to get the square root of both sides, which will give me r equal to the square root of x squared plus y squared, which is the formula given up here, and which is our distance formula, which is also the Pythagorean theorem. With that in mind, once I get the 3 side measures of my triangle, we're going to define each trig function. In this situation, I have sine theta. Sine theta is going to be the measure of my y over the measure of r. Cosine theta is x over r. Tan theta, or tangent theta, is y over x. So even though these are pronounced a little bit differently, these are the shortcuts for them. So sine is actually S-I-N-E, cosine is C-O-S-I-N-E, and tan is tangent. And theta is the angle that we're talking about that's in standard position. Down below, we have the reciprocal of sine, which is cosecant. We have the reciprocal of cosine, which is secant. And we have the reciprocal of tangent, which is cotangent. And it's easy to identify that they are reciprocals because sine is y over r, while cosecant is r over y. Similar for cosine being x over r, and secant being r over x, and tangent being y over x, and cotangent being x over y. Of course, there are constraints that your denominators cannot have a value of 0, and that's why you have associations to the right of those values where they cannot equal 0. Let's take a look at another example. The terminal side of an angle theta in standard position passes through the point 1216. Find the values of the 6 trig functions of the angle theta. Here we have 2 things we need to solve for. Number 1 states we need to find the value of r. 2, actually solve the problem, which is to find the value of the 6 trig functions. In the diagram to the right, we know that we have a terminal side in blue that has a point on it, and the point is 1216. Therefore, from that point, I know that my x value is 12, and my y value is 16. Also from the diagram, it illustrates that I'm given a right triangle. Therefore, all I need to really do is use the Pythagorean theorem, or the distance formula, to find the distance from the origin to the point 12/16. So let's use the Pythagorean theorem. In this case, I do want to find r, and here r squared equals x squared plus y squared. Substituting in, r squared is equal to 12 squared, which is 144, plus 16 squared, which is 256. Now, when we simplify that, we're going to have r squared equal to 400. R squared equal to 400, we take the square root of both sides, and I will get r equal to 20. That gives me the three values of the triangle I need to know to solve for the 6 trig functions. So let's proceed and solve for those 6 trig functions. From the previous slide, we know the definition of the trig functions, so let's continue. Sine of theta is y over r, which will give us 16 over 20. When we simplify, that'll give us 4/5. Cosine of theta, x over r. When we substitute, that'll give us 12 over 20. Or simplifying will give us 3/5. And tangent of theta, which equals y over x. When we substitute, is going to be 16 over 20 over 12, which gives us 4/3. Let's find the reciprocal functions. The reciprocal of sine theta is cosecant theta, which we know will be 20 over 16, but when we simplify, it will be 5/4. Cosine theta, the reciprocal function is secant theta, which will be 20 over 12, but when we substitute, it will be 5/3. And tangent of theta, the reciprocal is cotangent theta, and it is 4/3, but when we find the reciprocal, it's 3/4.